Good afternoon, everybody. Let's come over to the carbon dioxide system. As we all know, carbon dioxide is also a one-component system because carbon dioxide can exist in the water phase, it can exist in the liquid phase, and it can exist in the vapor phase. And since all these three phases which exist in equilibrium, they can be represented by a single chemical entity, that is CO2. So carbon dioxide system is also a one component system. So just like it is also just like the water system, this is the pressure axis and this axis is the temperature axis, and the salient features of this phase diagram are the curve OA, which is the vaporization curve OC, which is the melting point curve OB, this is the sublimation curve. There are three areas. This represents this area BOC. It represents the solid carbon dioxide. This area COA, this represents the liquid carbon dioxide, and the area below AOB, this whole area, this represents the vapor stage. These three curves, they meet at one point O, and this is the triple point, and all the three phases, the solid carbon dioxide, liquid carbon dioxide, and the gaseous carbon dioxide, they can coexist at this triple point O. Now let's see that values of the triple point are 5.2 atm pressure and the corresponding temperature is minus 56.4 degrees centigrade. Similarly, this 1 atm pressure curve, this cuts the sublimation curve only, it doesn't cut the vaporization curve, and this is cutting at minus 78.0 degrees centigrade. So these are the salient features, and here I have calculated the degree of freedom also for all the curves. Curve OA, this represents the vaporization curve, and it shows the effect of temperature and pressure on the vapor pressure of this liquid carbon dioxide. And the two phases which exist here are the vapor phase and the liquid phase. So it's a one component system, two phases are there. So the degree of freedom comes out to be 1, means it is a univariate system. If we fix the pressure or the temperature, then the other variable will automatically fix. This curve ends at A, and this is the critical point for carbon dioxide represented by 31.1 degrees centigrade of temperature. This is the critical temperature of carbon dioxide, and the critical pressure, which is given by 72.8 atmospheres. Now let's come to this curve OB. OB is the sublimation curve, and here we can notice two things. One is that this sublimation curve is at a very, this starts at very high pressure, 5.2 atm. Moreover, it is the 1 atm point, means the vapor pressure is 1 atm, and the vapor pressure 1 atm. It cuts at minus 78.0 degrees centigrade. This means that when the for carbon dioxide, it need not to be, suppose we take gas at 1 atmosphere pressure, the normal standard atmosphere standard pressure. If we take gaseous carbon dioxide at this pressure, and if we reduce the temperature, if we lower the temperature to minus 78 degrees centigrade, we will automatically get solid carbon dioxide without the appearance of the liquid phase, and that is why solid carbon dioxide is also known as dry gas. So this is one of the main features of this carbon dioxide system. Now let's calculate the degree of freedom along this curve OB. As we all know, the two phases in equilibrium here are the vapor and the solid state. And since it's a one component system, the degree of freedom according to this expression F equal to C minus P plus 2 will come out to be 1, means the system is univariate along this curve OB, and if we fix the pressure, the temperature will be fixed, or alternatively we can see that if we fix the temperature, the pressure will automatically be fixed. Now let's see this curve OB, which is the melting point curve for carbon dioxide. The two phases in equilibrium here are the vapor phase, the liquid carbon dioxide and the solid carbon dioxide. These two phases are in equilibrium, and similarly, just now we have calculated the value of degree of freedom will come out to be 1, and the degree of freedom will come out to 1, and so it is again a monovariant system. If we fix the pressure, temperature will be fixed, and alternatively if you fix the temperature, then pressure will automatically be fixed. We need to fix only one variable. Now let's come to this point on this diagram where all the three phases, they exist in equilibrium. They exist in equilibrium at this point. Again, this is known as the triple point, since the three phases in equilibrium are the solid, liquid and the gaseous carbon dioxide. And the degree of freedom will come out to be 0. X is equal to 1 minus 3 plus 2. This will come out to be 0. This means that the system is non-variant at this point. And since the system is non-variant, this means that we don't have to fix neither the temperature nor the pressure. Both are automatically fixed. The temperature at this triple point being minus 56.4 degrees centigrade and the pressure being 5.2 atmosphere. We need not to fix any of them. Both are automatically fixed, and hence the degree of freedom at this point is 0. Now, one main feature of this CO2 phase diagram is that when we have a look at this melting point curve, what we find is that it is tilted away from the pressure axis. This is the pressure axis and it is tilted away from the pressure axis. Very different from what we have seen in the water system. So when it is shifted, when it is tilted away from the pressure axis, this means it is having a positive slope, and what we can infer from this is that as we increase the pressure on solid carbon dioxide, the freezing point increases. The freezing point increases, or we can say the melting point increases as we increase the pressure on this solid carbon dioxide. Its melting point will decrease, or we can freezing point will increase when we increase the pressure. This is just opposite to what we have seen in the water system, that was due to the aromatous behavior of the water. And according to Clausius Clapeyron equation also, here the slope is positive, means dP upon dt, that is positive, and so this liquid, we can also infer that the liquid CO2 has more volume compared to the solid CO2, and so this OC curve, it is tilted away from the pressure axis, then the slope is positive. This was all about the carbon dioxide system. Thank you very much. Thank you very much.